This video will show how to measure distance using the VEX distance sensor. First, we'll cover how to set up the distance sensor, then we'll create a simple wall detection program using comparison operators, and finally we'll end off by incorporating new conditional statements in our code. Alright, so I've got my base spot here with a distance sensor attached on the front and plugged into port 7. From the devices menu, we can see different readings from the sensor, and like the name suggests, it measures distance to an object, and we can see that printed on the screen in either inches or millimeters. The sensor can also detect things like the approximate size of an object, along with its approach speed. It's got a small laser in the front that shoots at a beam of light directly in front of it, and when that beam of light hits an object, it bounces back to the sensor, and it times how long it took to travel to the object and back to the sensor to figure out how far away the object is. Like all sensors though, the distance sensor isn't perfect. Sensor noise might give readings that are slightly too close or too far from the actual value, and the sensor itself has drawbacks as it won't be able to see super reflective surfaces like glass or mirrors. So if I hold this mirror in front of it, it says the distance is 60 inches, even though it's about maybe 3 inches in front of it. And the reason why is because it's actually sending that beam of light off somewhere in this direction, and then it's coming back to the mirror and back into the sensor. So it's unable to figure out that the mirror is right in front of it unless I point it directly at the sensor. Back over in the VEX IQ editor, for our first program, let's make something simple that just drives forward and stops if the distance becomes less than 6 inches. As always, first thing we want to do is set up our sensors by going to File, Open Examples, Templates, Base Spot with Sensors, and this sets up all the motors and sensors for our robot. To start things off, we'll use a drive forward, and then a wait until block, and then a stop driving. Now I've got to fill out this block here with something that will make the robot stop driving. But if I head over to the Sensing tab and down to our distance sensor, you'll see there isn't really a good block for something to go in this hexagonal shaped hole. There's object distance in millimeters, object velocity, is the object small or has the distance sensor found an object. But remember, we want the robot to stop driving when its distance is less than 6 inches. And if I use this object distance one, which is a round block, it doesn't fit in this hexagonal shaped hole. And the reason is because these blocks are not the right data type for the wait until block. Remember, the wait until block only takes yes or no questions called booleans, but our round block here is just a number that represents the object distance in inches. So in order to turn our distance number into a yes or no question, we have to use a special block called a comparison operator. They live over in the green section called operators. And you'll see there are 3 comparison objects. There's greater than, less than, and equal to. Since I want the robot to stop when the distance is less than 6 inches, I'll use the less than block. And since it's a boolean, it has this hexagonal shape that can fit into the wait until block. And it has 2 spaces for round blocks inside, so I can put our distance in the left one here. And if I say wait until the distance is less than 6 inches. Now if we run our code, the robot starts driving forward, and then it waits until the distance is less than 6 inches, and then it stops driving. A helpful tip for using the comparison operators is to put your variables first on the left-hand side. I could have just as easily written it as 6 is greater than the distance, but it just sounds a little weird in your head. For example, you might say, if your speed is greater than 60 miles per hour, you're going too fast, and not if 60 miles per hour is less than your speed, you're going too fast. Both of those sentences mean the same thing, but the first one sounds fine while the second one sounds pretty weird. It's the same reason why I want to say wait until the distance is less than 6 inches, and not wait until 6 inches is greater than the distance, because I have to stop and think about what that actually means. So do yourself a favor and make your code easier to read by putting the variables first. Now, one thing you might be wondering is why we aren't using the equal to block. After all, if you read our code after putting it in the equal to block, it still makes sense. Drive forward, wait until the distance is equal to 6 inches, and then stop driving. But you'll see when I actually run this, that isn't what happens. The robot just keeps driving forward. To help show what's going on, I wrote a piece of code that prints the distance value to the screen. And you can see that our value has got a decimal point along with a bunch of digits after it. Because like I said before, sensors aren't perfect. They can be pretty good, but sensors like these tend to have small amounts of random noise that causes some fluctuations. This is why our code isn't working when using the equal to operator, because I can try as hard as I like to make it exactly 6 inches, but with the sensor noise, it's almost impossible to get a perfect 6.000000. So in this case, we need to use a less than comparison to make our code work like before. Now let's change things up and make the robot always stay 12 inches from the wall, meaning it will drive forward if it's too far and back up if it's too close. To do this, we're going to use a new block called the if-else block. It's just like the if block, but it's got this added else section that only gets run if the condition isn't true. So in the condition here, let's put something like, is the distance greater than 12 inches? So if the distance is greater than 12 inches, then we can do something in here. And if not, meaning it's less than 12 inches, we can do something else. We want our robot to always stay 12 inches from the wall. So if our distance is greater than 12 inches, we need to drive forward. But otherwise, if it's less than 12 inches, that means we're too close and we need to drive in reverse. We also need to wrap this whole thing in a forever loop so that it keeps driving forward and reverse as it changes. If we run this code, we can now see that our robot drives forward if the distance is too big, but it also backs up if it gets too small. The robot's constantly checking its distance to the wall and deciding whether to drive forward or reverse. But I'm not the biggest fan of this little back and forth action we got going on here. So to fix this, let's create a little dead zone where the robot doesn't move at all. To do this, we can use an else if block, which is just like the if else block, but it has space for added conditions. And it just checks each one of them in order. If the first one's true, then it gets run and is done. But if not, it'll check the next one. If true, it gets run and is done. But if not, it'll check the next one, and then the next one. And then eventually, if all of them are false, it'll just run this else part here. In our case, we only want 3 conditions. And for the first one, say, if the distance is greater than 12 inches. Let's have a dead zone of about 2 inches. So we'll say if the distance is less than 10 inches. And then otherwise, it means it's between 10 and 12 inches. So if we're greater than 12 inches, that means we're too far from the wall, so we still need to drive forward. But otherwise, if we're less than 10 inches, that means we're way too close to the wall, so we need to drive in reverse. And otherwise, that means we're somewhere between 10 and 12 inches, which means we should stop driving. Now if we run our code, the robot no longer does that little back and forth motion because there's a 2-inch dead zone where it's closer than 12 inches, but further than 10 inches, so it just stops driving. And with that, that's just about it. If this video helped you out, don't forget to click the like button to help others find it, and feel free to subscribe so you can stay up to date with any new videos. Thank you so much for watching.